and guest Stephen Porder, and you also have Charles Clarkson, our Avian Research Director, joining us. So I will go ahead and do a formal introduction of the topic and our speaker, and also what brings us all here today for the next hour. We definitely want to maximize our time with Professor Porder, so I will be brief, and we want to leave time for questions. So the last 15 minutes or so, we'll have questions. As usual, there is the chat function where you can go ahead and post your questions, but just know that we're going to hold those questions to the last 15 minutes of our webinar. So once again, welcome everyone. On behalf of Audubon, we're grateful that you're spending the next hour with us. And I am so excited that we have Brown University's Professor and Associate Provost for Sustainability, Stephen Porder, doing this webinar today on climate change solutions in Rhode Island and beyond. Professor Porder will share more about his background. I got to know Stephen last year where he joined the Audubon board, and I have to say it's been truly great to work with him as we're navigating science-based solutions and really trying to address climate change in our mission. So Stephen will talk more about Audubon's mission, but for any new faces that are joining us today or new to Audubon, we have been around for 125 years, working to protect birds, wildlife, and their habitat, and we do that through conservation, education, and advocacy, which brings us here today for the benefit of people and all living things. We are a private, independent, membership-based organization, and currently we are managing well over 9,500 acres of conserved habitat to protect diverse ecosystems that are really important as we adapt to climate change. So you will hear a lot about climate change today. And lastly, I want to say in terms of the advocacy work that we do at the State House, it's all really driven by the science and by climate change. So back in 2020, Audubon adopted a strategic plan where we really focused on centering the climate crisis and everything that we do from education to conservation and advocacy. If you do not follow our Eagle Eye newsletter, where we provide advocacy updates and the topics that we are advocating for, from solar siting to decarbonizing the building sector, environmental justice, farmland preservation, I highly encourage you to look through our advocacy tracker. Paige Terrian has done a tremendous job in laying that all out for the public and for Audubon members and supporters to follow along. So I will stop there. I want to reserve most of our time for Stephen's presentation, but again, I will be around and happy to answer questions with Stephen, Charles, and Paige towards the end of the webinar.
Great, thanks, Priscilla. Can everybody hear me okay? Priscilla, can you hear me?
Yes, excellent.
Okay, awesome. Yeah, so let me just very briefly introduce myself again. So my name's Stephen Porder. I'm a professor at Brown in the Department of Ecology, Evolutionary and Organismal Biology, as well as a fellow in the Institute for Environment and Society. And I also serve as the Provost for Sustainability. For the first 15 years of my post-PhD career, I researched tropical rainforests and forests in general and what controls how much they grow. And why that differs from place to place. But more recently, I have been in charge or trying to lead Brown's sustainability efforts broadly, and particularly their decarbonization efforts, with an eye towards leveraging that knowledge towards broader decarbonization of our city here in Providence and our state and our region. And it's really at that intersection that I want to talk today. So I'm going to jump right in. As Priscilla mentioned, the chat function is available, and I will be happy to answer questions at the end, but please do mute yourself if you aren't muted already, and drop questions in the chat rather than jump in the middle of the talk, just so we have time to get to everyone's questions. Okay. So as Priscilla mentioned, the Audubon Society of Rhode Island mission is to protect birds, other wildlife, and their habitat through conservation, education, and advocacy for the benefit of people and all living things. And what this talk is really about, at least in part, is how we should be thinking about that mission in the context of change. And I'm going to give several examples of change, or an example of change, before I get to climate change, because I think it's very relevant to the conversation vis-a-vis how we make a transition to fight climate change. And I pulled this from a blog on the Audubon website in January. And I thought it was a very interesting blog post because its title is Preserving a Disappearing New England Habitat. And I think that's something that most people who support Audubon would think is an important thing. But I thought it was very interesting for the reason that's highlighted below. Without proper management, most of these breaks in the forested landscape would revert to shrub thickets and eventually forest in the process of field succession. And this blog was arguing that that would be a problem for the birds that need open habitat. And that's certainly true. On the other hand, those forests are carbon sinks. They are places that would suck up carbon. And so inherent in this blog post is a tension that is facing many conservation organizations, in fact, facing all of us, which is how do we assess the different values that different landscapes have against each other? The value of open habitat, in this case for birds, versus the value of forests in the other case for carbon. And I'll talk about that trade-off more when we begin to think about forests or other habitats versus solar panels in just a few minutes. But the point I want to start you with is that we do not, and we have not for a very long time, lived in a static world. And I'm going to illustrate that with some beautiful photographs from a diorama series at the Harvard Forest, which is up in Petersham, Massachusetts. So if you were to go to Petersham, Massachusetts, which looked roughly like Rhode Island, except a bit hillier in 1700, you would have seen what we would call now an old growth forest, big trees, mixed conifers and deciduous trees, bigger trees than we see anywhere in the region today. But by 1830, that landscape had been completely denuded for farms, and the trees had been used for the masts of ships and for building of houses and for heating and for other construction projects. And so the landscape was completely different than it was in 1700, and more importantly for this talk, than it is today. That landscape persisted through the 1850s, but the advent of railroads and the movement of farms in general, more prominently to the Midwest of the US, began the process of land abandonment and regrowth of forests. By 1890, though, the landscape was still fairly unwooded. This is actually now moving into the photograph era rather than just dioramas. And today, if you look at that same view, the landscape is completely forested. And these are the forests that people are fighting to protect today. The point I want to make with this diorama is simply that that nothing here is static. There are no old growth forests really left in New England. They have been cut before, they have regrown. And this graph here shows you that process. So on the colored lines at the top show you the New England states and their percent forest cover from 1600 through to today. On the right, the dotted line is just showing you the population in New England. And I'll highlight Rhode Island because it's a bit of a messy diagram. Rhode Island went from about 85% forest in 1600 down to something like 30% forest in the middle of the 19th century, and back up to about where it is today, 60% forest or so by the middle of the 20th century. And then there's been a slow decline since then. So what is the proper baseline? Well, it depends what you're interested in. If you're interested in open habitat, if you're interested in more forests, right, is not static. So given that we already don't live in a static world, how then do we think about the modern era of climate change? I want to take a minute to show you a video, and I want to take another minute before that to explain the video. So this is obviously a map of the world, and the colors on that map are indicating the temperature of a particular place relative to its 20th century average. So in this particular image, what you'll see is during the time period of 1880 to 1884, hot colors indicate that that particular place was warmer than the 20th century average, and cool colors indicate that it was colder than the 20th century average, mid 20th century. So for example, the orange that hopefully you can see here in West Africa indicates that West Africa during this time period of 1880 to 1884 was about a degree Celsius warmer than West Africa is in the middle of the 20th century. In contrast, the Western United States during the time period 1880 to 1884 was roughly 1 degree Celsius cooler than it was in the middle of the 20th century. And what I'm going to do now is play this forward in time. It's a nice soothing display of colors. And what I want you to do is keep your eye on a particular place and also try and see if you notice any really big changes. Okay, so here we go forward in time. We're now in the 1890s, the 1900s, the 1920s, the 1940s. You can see there's a lot of variability. Warm, cool, different places. But you can also see that the 20th century, end of the 20th century and the beginning of the 21st have been the warmest on record and are now rapidly approaching the warmest in several million years. We are not living in a static world. Already, the climate has changed substantially. So I drove last week to New Hampshire to get some last end of season skiing around Mount Washington. And I drove up, not this exact route, but a couple of hours north of here. And I put this Google map up to simply say that the Providence temperature in 1900 was like what Manchester, New Hampshire is like today. The climate has already migrated a 2-hour drive since 1900. We are that much warmer already, which you could see in the global map, but now I wanted to show you in a local map. So why is this happening? Climate science, you will hear often, is very complicated. It is very complicated, but it's also very easy to sum up. I'll sum it up first with a cartoon. On the x-axis, I'll show the total amount of carbon dioxide and other greenhouse gases that humans emit, have emitted since industrialization, mostly by the burning of fossil fuels. On the y-axis, I will plot the global temperature rise. This is what the relationship looks like. It's a direct linear relationship. Now, of course, this is a cartoon, but I'll show you the same data from the Intergovernmental Panel on Climate Change. So this is a graph from their latest assessment report, and you can see the same axes, temperature rise on the y-axis, total amount of CO2 on the x-axis. What I want to show you here, the black line is showing you historical emissions, and we have already emitted about 2,400 gigatons of carbon. There's no reason for you to have that unit in your mind, but we've already emitted that much. And that has warmed the planet by about 1.2 degrees Celsius on average. Rhode Island has warmed a little more than 2 degrees. If we would like to limit warming to only 1.5 degrees, which I think is very unlikely, but a very laudable goal, we can only emit about 400 gigatons more, which is about 7 years of emissions at current rates. The cost of damages, both dollar costs and costs to humans and ecosystems, goes up dramatically with each 1/10 of a degree it warms. So while we are unlikely to keep our warming to 1.5 degrees total at the global scale, every extra ton of carbon that we keep out of the atmosphere is keeping us further from a precipice that we don't know exactly where it is. We do know that already warming is causing sea level to rise faster and faster. And here in the ocean state, that is a major issue. We are already seeing communities and towns retreat from the ocean, and we will continue to see that. Sea level has increased by about 0.2 meters or 20 centimeters between 1900 and 2018, but the rate is going up more quickly than that. So the rate in the early part of the 20th century was 1.3 millimeters a year. Then it rose to 1.9 millimeters per year. It's now at 3.7 millimeters per year. And we know that although warming will stop within a decade or two of when emissions cease, sea level rise will continue for decades, probably for centuries after we stop emissions. So given that we live in a place that was deforested and is regrowing, and given that we live in a place that is changing dramatically in climate as a result of human emissions of fossil fuels, how then do we think about this mission to protect birds and other wildlife and their habitat through conservation? What does that mean in a changing world? And I would submit that it no longer means simply boxing off habitat and trying to protect it, although that's very important. So what I'd like to think about in the rest of this lecture is how should that mission of protecting habitat evolve to think about climate change? And really, how do we think about the trade-off between protecting habitat, sorry, not from conservation, protecting habitat for conservation versus protecting habitat by using some land to help limit climate change, that is, to produce energy. So now let's shift from Audubon's mission and climate change to the reality of emissions that come from Rhode Island. Rhode Island emits about 11 million metric tons of carbon dioxide or equivalent gases per year, and most of that comes from transport, heating, and electricity, 88%. That's an extraordinary opportunity because technology now exists that will allow us to produce electricity, transport our vehicles, and heat our buildings with renewable power, with renewable carbon-free power. So Rhode Island's Office of Energy Resources has tried to study this transition and produce a report recently looking at the demand for electricity between now and 2030, because we are mandated to achieve 100% renewable by 2033. So this graph is kind of complicated, kind of busy. So I'm going to walk you through it. On the x-axis is time, so the years 2020 through 2030. The y-axis is the amount of power consumed from electricity. The dotted line I'm going to skip the dotted line. The bars are showing you the amount of carbon-free power that we could generate, presuming that Revolution Wind, which is in the midst of the approval process, comes online. The orange line, and I'm hoping you can see my cursor, shows what we would need to do in order to meet Rhode Island's electricity demand, which is this black line here. So we would need to get carbon-free power equivalent to this orange line, which means by 2030, there's a gap between what we will need to have 100% renewable electricity and what we will produce with current approved projects or almost approved projects, since Revolution Wind is not yet fully approved. So there's a gap of 4,600 gigawatt hours. So I'll just give some very brief terminology. You'll hear me use the word mega, which means million, and giga, which means billion. If you are paying attention to energy production stuff in the state, you might hear the word capacity, which is the maximum output of a power plant or a wind farm or a solar field. And then there's a capacity factor. And that just means, for example, that solar panels don't produce 100% of what they could 24 hours a day because there's no power coming at night. And so typically the capacity factor is like, I don't know, 0.2, I do know, 0.2 or something like that for a solar field. And so you have to reduce the total capacity by 80% to get the average capacity. So let me give you an example, a concrete example. This is the Dry Bridge solar site in southern Rhode Island. It's been constructed for some time, although it is still not interconnected. I'm happy to talk about that if you're interested. This site is about 220 acres of solar panels built on a former gravel pit. So let's look at these capacity. The field capacity of this is 40 megawatts of AC power. It has a capacity factor of about 20%. So that's an average capacity of 8 megawatts. Over the course of a year, that will produce 8 megawatt hours times 24 hours times 365 days. This is average production, which is about 70 gigawatt hours. Now, I know that's a lot of numbers, so that's fine. Don't have to memorize them. Just remember that 70 number for a minute. So now let's go back to this graph. This graph says, well, look, if Rhode Island wants to be 100% renewable by 2030, we have to fill 4,600 gigawatt hours with renewable capacity. That solar field I just showed you provides 70. So one option is to build 65 200 and some acre fields of this size and get them all interconnected, get them approved, get them through community review, all of that stuff. I think that's unlikely to happen, but we'll come back to that in a minute. Of course, the other big renewable source that we're talking about here in Rhode Island is offshore wind. So this is a screenshot from the governor's website announcing a request for proposals for another 600 to 1,000 megawatts of offshore wind. So let's think about that in context. Here's our gap of 4,600 gigawatt hours. Let's say that that offshore wind, and remember that doesn't include the Revolution Wind project, which is already going in the approval process, although it has not yet started construction or even been fully approved. If we were then on top of that to add another 1,000 megawatts of offshore wind, you would fill much of the gap. But it would still leave about 1,000 gigawatt hours left that would need to be filled with on-land renewables. And most of that is likely to be solar. And that's with today's electricity demand. But remember that we're also going to need to electrify our transportation with electric vehicles and our home heating with heat pumps instead of gas or oil furnaces if we're going to reach our climate targets. So this graph is just showing you that we expect electricity demand to roughly double between 2030 and 2050, let's say, if our goal is to be 100%, to be net zero by 2050. All of that to say, if you do all that math out, we'll probably need about 30 solar fields of this size in the state in order to reach our decarbonized goal of net zero emissions by the middle of this century. And just to give you a sense of how big this is, because it's hard to see, I mean, there are some houses. I'm just going to give you a flyover during construction. You can see pickup trucks and people. Parking lot. This time, only half the panels were on the ground. The rest is just racking. But that's a big field, right? That's a big field. So how do we think about that? Well, this is what the Rhode Island land use and land cover looked like in 2020, thanks to Terry Meyer for putting this map together. And the dark green is showing you forest. It's about a little over 300,000 acres of forest, really depends on how you categorize forest. And the bright pink around Providence is obviously high density residential. And there's a smattering of other land uses. For context, I've put a solar panel in Massachusetts, nicely, that roughly represents about 6,500 acres. For those of you who saw my previous talk, I've gotten some updated numbers on the Rhode Island solar field. And so these numbers will be slightly different than what you saw in my previous talk. Just FYI, I can explain how that is. It's not a big difference, but in case you were remembering back to the other talk, I just wanted to make that clear. So where could we put that many panels? Right? The panels roughly the size of this box. They don't all have to go together, but they should be located near where electricity consumption is happening, because that is more likely to get interconnected and used more efficiently. So it doesn't have to be all together, but it does have to be in places where political opposition is low, where interconnection is possible, where the process can go quickly, because we're going to need a lot of them. So they could go on rooftops. They could go on commercial and industrial lots. They could go on landfills or brownfields. They could go on former gravel pits like the one that I showed you at Drybridge, although there are not many big gravel pits in the state. Or they could go on parking lots. I tried to Google search for a big canopy parking lot in Rhode Island, and as far as I know, and please correct me if I'm wrong, there isn't one. So this is a national grid mock-up of what one might look like. There certainly are some in other places. there are enough sites like this to fill the renewables gap, presuming that offshore wind comes on strong, that Revolution is approved, and that there is another 2 of that size approved. But onshore solar in parking lots and on gravel pits, in parking lots or on rooftops or on any is more expensive. And I'll show you that in a minute. Although these sites do address many other concerns. So we're going to have to weigh higher costs per panel of having them over parking lots to the lower costs of having them in places that we might not want to cover with solar panels as much as we would like to cover parking lots. And this is just to give you an example. Here I'm showing you from a report by the Office of Energy Resources and Synapse, the total potential in various places. So rooftops, landfills, parking lots. This is the amount of electricity possible. So we need a couple thousand gigawatt hours. So there's plenty of capacity. What I want to show you here is the cost. So if you put things on the ground, it's about $122 per megawatt hour. If you put things on rooftops, it's at least 50% and probably actually more like 100% more expensive at scale. So another way to say that is if you put things on the ground, you get twice as many panels for the same price as if you put them on rooftops or on parking lots. I will point out that parking lots are a big tax strain on almost all of our municipalities, and our car dependence, although it's not the main focus of this talk, is inherently discriminatory against people who cannot afford cars. So this is just a example, but 60% of low-income households do not have a vehicle, whereas high-income households with a vehicle, only 24% of low-income people have a vehicle. So parking lots are essentially tax losses for cities that are benefiting high-income people with cars versus low-income people without cars. And so in other parts of the world, you're starting to see government movement. So in France, for example, the Senate approved a law that would require almost all large parking lots to install solar panels. They would have to cover 50% of the lot surface area by 2028 or face a heavy monthly fine. So Rhode Island could do this. That would certainly change the calculus for where we put our solar panels, but so far that has not happened anywhere in the United States. So one thing you hear a lot in the conversation about solar panels is that it's a terrible idea to ever cut down forests to put up solar panels because forests store carbon. And that's the whole point of putting up solar panels, is to keep carbon dioxide out of the atmosphere. Why would you ever cut down a tree? It's already taking carbon out of the atmosphere. And so I want to spend a little time talking about whether cutting forests makes sense from a climate change perspective. So what I really want to give you a sense of is how much carbon are we really talking about here? So we know a lot about carbon in forests from this really cool instrument. We know a lot from many, many decades of studies, but on the International Space Station right now is a scientific mission called JEDI. I'm stealing this video from NASA because they're good at making cool videos. And JEDI is a series of LiDAR lasers that is constantly sending pulses to the ground and measuring the biomass of forests all over the world as the International Space Station circles the globe. This is now billions and billions of data points of how much biomass and how much carbon is in forests. It's a truly incredible instrument, and the scientific lead actually happens to be at Brown. His name is Jim Kellner. It's an amazing project, so I'm kind of just showing it off, but it's also the first global assessment of really how much biomass, how much carbon is stored in forests worldwide at a very high spatial resolution. And so from that data, we can pull all of the pixels from Rhode Island, which I've done here, and do a little bit of carbon math. So Rhode Island's forests store about 110 metric tons worth of carbon dioxide per acre. So You don't need to remember that number because I'm going to come back to it, but we know very much how much carbon, we know very well how much carbon is stored in Rhode Island's forest. That's the point I want you to take from this slide. We also know, thanks in large part to decades of work at the Harvard Forest in Massachusetts, but also elsewhere, exactly how much carbon dioxide these forests are sucking up out of the air each year. So I'm showing you a picture that I took from the top, or a picture from the top of a tower that's up above the forest canopy at Harvard Forest in Petersham, Mass. And this tower and others like it are measuring instantaneous fluxes of air and the concentration of carbon dioxide in that air 24/7. And if you do that day after day after day after day for years and decades, you start to see the breathing in and out of carbon dioxide from the forest, and you can actually measure how much carbon dioxide the forest is accumulating each year. And so we know from data like these that Rhode Island's forests are growing back from that clearing in the 1800s and taking up about 5 metric tons of CO2 per acre. So that's great. They store about 110 equivalent of CO2 per acre, and they take up an extra 5 every year. So let's do some carbon math with that. Solar panels don't take up any carbon from the atmosphere, but they do keep carbon dioxide out of the atmosphere because they are replacing fossil fuels. Forests store carbon in their trees, and they're sucking up a little extra carbon every year as they regrow from that clearing in the 1850s. So let's do the math. Given our current grid, and I've used very conservative assumptions here, these solar panels in Rhode Island will reduce carbon dioxide emissions by about 70 metric tons of carbon dioxide per acre per year. Okay, so that's on the solar panel side. Rhode Island's forests, well, they contain about 110 metric tons of carbon in the wood itself per acre. And they're taking about 5 tons of carbon out per acre per year from the air. So what does this mean? What it means is that solar panels win on a carbon-only consideration. And I'm not, before you get all mad at me, I'm not saying that forests are only carbon. But from a carbon perspective, it actually makes quite a bit of sense to clear some trees and put up solar panels. Because in less than 2 years, these panels will be responsible for keeping more carbon out of the atmosphere than Rhode Island's forests are taking up. Solar panels win from a carbon accounting perspective. And of course, I want to reiterate, forests are more valuable than just carbon. But our forests are under a dire threat from climate change itself. And so it is, in my opinion, no longer sufficient to protect every tree but not to push forward the energy transition. Now, if you look at our Rhode Island greenhouse gas inventory, you'll see this embedded in the data. So I showed you the data up above before. 40% of our emissions come from transportation. 20% roughly come from residential heating, another 20% from electricity, another 9, let's call it, percent from commercial heating, right? So of all of those emissions coming from all those things, our 300,000 acres of forest are actually doing us a great job. They're taking out 7.2% of our fossil fuel related emissions. And that's wonderful. But that's 300,000 plus acres of forests, and they're only sucking up 7% of our fossil fuel emissions. Forests can't fix this problem for us. They can't clean up the atmosphere for us. We have to stop emitting CO2. That means we have to stop combusting fossil fuels. And we really only have 2 ways to do that in Rhode Island: offshore wind and onshore solar, and maybe some wind too, although that's probably less efficient. So I'm almost at time, and I want to make sure I have time for questions, but I do have some thoughts to end with. I'm going to come back to the mission of the Audubon Society, which is to protect birds, other wildlife, and their habitat through conservation for the benefit of people and all living things. In my opinion, and I think Dr. Clarkson would agree with me, the 2 biggest threats to birds in this century will be climate change and habitat loss. That's true globally. It's probably true here in Rhode Island as well. Slowing climate change will require using more electricity than we currently use, because we're going to need to use electricity for transportation and for home heating and for residential heating. And that will roughly double our electricity demand. And that electricity must come from carbon-free sources like wind and solar. While forests and grasslands are critical habitat, they are also the cheapest place to put solar. And so if we want to put the most panels out that we can for a given amount of money that we're willing to spend on this problem, you're going to get more of them if you put them in the places where it's cheapest to put them. For those who argue that the carbon savings from forests make it crazy to ever cut down a tree and put up a solar panel, that's just fundamentally untrue from a carbon accounting perspective. I study the carbon cycle for my profession, and I can say unequivocally that solar panels are better than Rhode Island's forests at keeping CO2 out of the air. That doesn't mean we should cut them all down. We don't need to cut them all down. It just means that from a carbon perspective, it's not even close. So one question we should ask ourselves is, are we, and by we, I mean the collective society, if decarbonization is an issue, and we are absolutely dead set against ever clearing any land, then we will have to pay more to decarbonize. And the question is, how much more are we willing to pay? Putting it another way, for a given amount of money, what is it worth having? Is it worth it? And to whom is it worth it to have more habitat and less solar? So I'd like to talk about that in the context of Audubon. So here's Audubon's visitor center and nature center in Bristol. I biked by it this morning. It was lovely as always. Audubon has space on its property to put up solar panels sufficient to power its location. And it won't need to clear any trees probably in order to do that. So, but it will be more expensive to put those panels over their parking lot than over on the ground elsewhere on the property. Is Audubon willing to pay more to cover its parking lot with solar? Should it? It could heat and cool its buildings. It could charge vehicles. Right? These are questions we all need to be asking ourselves. If we want, how much do we value decarbonization? How much do we value where we put those panels? How much do we value the habitats that we change? I'm just using Audubon as an example. But more broadly, will our organization commit to a fossil-free future? And how will it, fossil fuel-free future? Sorry, that's a mouthful. And how will it do that? And is this where Audubon should start? This is a question, I think, for our board, for our community, for our members to weigh in on. So with that, I think I'd like to wrap up. I'm at about 40 minutes past the hour, which is just where I wanted to be, so that there'd be some time for questions. Please post them in the chat if you can, and Paige and Priscilla will potentially unmute people. I'm not exactly sure how that's going to work. But I hope that you learned something. I hope that you have lots of questions, and I look forward to discussing. I will just stop my screen share.
Thank you, Steve.
And be happy to answer any questions if I can.
We already have a few questions in the chat, so I say let's start off with those. I think they're good points of discussion, and then we'll open it up to other folks via the chat, and then figure out if we can unmute folks to ask their questions live too. Starting off with a really good one. This is something that I think the state has spent a good amount of time analyzing, is what's behind the math on why open land is less expensive than constructing on already disturbed land buildings, which we know is like the opposite for the residential market. So ground mounted are much more expensive than rooftop systems. So what percentage of the cost is land acquisition? And Stephen, I did post on the chat the solar opportunities study that Synapse did as a reference as well.
Yeah, so Priscilla, you probably know the answer to that question better than I. Do you want to jump in?
Yeah, so one of the things when we're thinking about previously disturbed sites, whether you're thinking about commercial rooftops or you're thinking about landfill sites, brownfields, for example, and Stephen, you talked a lot about carports. there is a higher cost to development. For example, in landfill sites and brownfield sites, they have to be remediated, they have to be cleaned. Previously disturbed sites typically have toxins in them. There are things, of course, that the state could do to help levelize the costs for all of us on that and make it less expensive for developers, which we are working on that statewide to really maximize that kind of development. But also, Stephen, you alluded to the issues of transmission. Sometimes it's not as straightforward for these projects to get connected onto the grid. So there's just a lot of different layers and variables. And then sometimes when you think about a commercial building, if it's not new development, you're thinking about the age of that roof, whether it needs repairs. And that's why I posted that link to that study that was done, because for a while we had been hearing from developers that it was more expensive to develop on these previously disturbed sites. So it was great to actually do the analysis and see why it is more expensive. And the data is there. Unfortunately, the way our programs have been designed, the unintended consequence is that it has been cheaper and more profitable for the developer to go develop solar panels on open space. There has not really been any incentives to drive development towards these disturbed sites and to really levelize the cost of them for developers and also for ratepayers.
Can I also just jump in and say, given the scale of what we're going to need, we're going to need a lot of solar panels. And if you break those up into very small units, the cost goes up of getting all of that permitted and whatever. It's not always the case, but there is an economy of scale if you can put 200 acres of panels out there that you don't get if with a whole bunch of small parking lots, each one of which could fall through because the landowner didn't do this, or there was a problem you didn't anticipate or whatever. And so one of the things that we're learning is that the cost of panels themselves has dropped remarkably. But the cost of labor and the cost of permitting and the cost of unanticipated consequences, those all are very real impediments to these projects. I actually just had someone out at the house to look at solar at my house. And I asked whether I could put some ground mount solar in the backyard. And they said, there's no way you'll get that approved, even though it's in your backyard, that it just won't happen. I thought that was kind of interesting because it seemed like it made sense to me. But these things are, it's not that they're immutable. Laws can change, incentives can change, all of that stuff is true. We have no time left. We have dithered on climate change for half a century. And we are really up against the wall. And so the question is not, is the solution perfect? We're long past a perfect solution. The question now is, what is the least bad? And in my opinion, as a global change scientist and someone who studies forests, rapid deployment of renewables, even at the cost of some habitat, and at the cost is what we have to do. If we want to try and even catch up to the climate crisis at all. That does, and so that's sort of, Rhode Island can't fix it, but if no one does it, and it won't get fixed. So I don't know. That's sort of my take on this issue.
Thank you, Stephen. Appreciate that perspective. And Charles, feel free to also chime in on the next round of questions. Thinking about the State of the Birds reports that were recently published by Charles Clarkson, our Avian Research Director. So the next round of questions, Stephen and Charles, have to do with the clearing of forests. And someone asked, what about threatened and endangered plants, animals, and critical habitats? And hand in hand, if we cut down some forests, aren't we causing more habitat loss for birds and animals? So if you could both speak to that, that would be great. And I think in so many ways you've answered that, Stephen, with the biggest threat that all living things are facing, which is climate change. But I think it'll be great to dive in more into that question.
I'd love Charles to answer that from a bird perspective.
Yeah, sure. I'd be happy to take a stab at that. I would say one of the biggest reasons that the Avian Research Initiative exists is that we have this new kind of New World Order at Audubon, as guided by our strategic plan, to understand what it is that we're protecting, to include the species assemblages that we find on our refuges, how those species are faring at a regional level. So within the Mid-Atlantic and New England region over a 50-year period, how populations are trending through time, so that we can better understand and take stock of what it is that we are currently protecting and set our sights on what it is moving forward we need to focus on, whether that's a particular bird population, a particular avian community, or habitats that are threatened and are in decline. There's been quite a bit of work within the solar panel siting field to show that there are some distinct benefits of solar panel construction in natural areas, and setting aside the selective deforestation to construct solar panels. If you talk about the potential upsides of solar panels from a wildlife perspective, there's a lot of work that shows that solar fields, if created effectively, can serve as really valuable corridors for wildlife movement and can help with connectivity problems between parcels of untouched contiguous forest tracts. So in that way, we actually facilitate the movement and basically the genetic propagation of all of these species that we're trying to conserve. We also know we're staring down the barrel of a complete collapse of our pollinator species, insects and some bird populations too, that provide so much of our pollinating services. And there are studies being done to show that solar panels that are constructed, and instead of just being constructed outright on a gravel field, are constructed within wildflower areas and replanted to promote meadows and shrub habitats, creates additional habitat for things like early successional species like towhees, prairie warblers, indigo buntings, all species that have been in decline for quite some time. And it also promotes pollinator species such as bees and other pollinating insects. And that not only has an overall positive effect on our pollinator populations, but they found that agricultural areas that are adjacent to these locations benefit also from this advent of these solar panel fields that are promoting the growth of these localized pollinator populations. So, Audubon on the one hand has this very John Muir approach to its protection of and conservation of land, which is, we recognize that nature has an intrinsic value, which is it is valuable because it exists. All of these plants and animals that share this planet with us have been on this planet for far longer than we have. We're talking about birds and plant species that have been here for tens of millions, if not hundreds of millions of years. And so by virtue of their evolutionary history, they are intrinsically valuable, and we should do absolutely everything in our power to make sure that we're not destroying the intrinsic value of nature. So these discussions in terms of where solar panels need to be placed, in terms of their ability to provide the relief from carbon dioxide pollution that we seek, whilst not destroying these incredibly sensitive habitats, is all part of this really responsible siting work that's going on. Very similar to the work that's being done with regards to offshore wind, in the placement of turbines based on sound siting protocols that looks at how benthic communities, whale populations, and birds utilize these areas, and making sure that we're doing everything we can to site these projects responsibly. So an analogy that I oftentimes use is that the wheels are in motion here. It's taken us forever to get to the point where we have the ability to start ramping up our renewable resources. It would be a shame if right now we stopped this forward momentum. And so what we think about in the conservation community is that the wheel is in motion, and what we really need is a very educated, compassionate, and knowledgeable driver behind the wheel of this bus, right? Because it's moving and we need to make sure that it's going to move in the right direction and get done correctly with as minimal damage to the environment, to the habitats and the organisms that are contained therein as possible. Stopping it altogether would be essentially sticking the spokes in that wheel and setting us back decades in terms of our ability to meet this very real demand to find a future that is free of carbon dioxide and the issues contained with its release into our atmosphere. So it's a very multifaceted issue. And I'm certainly not advocating that we just go cut down forests to put up solar panels, because that's not a good idea, and it should not take place. But what we should start doing is thinking about how we can utilize these solar fields to actually promote biodiversity, promote connectivity, promote genetic transfer between isolated populations. And all of these things are things that we can do if, again, we make sure that we're siting things as intelligently as possible.
And I would just, so thank you, Charles, that was great. I would add two thoughts to that idea. One is, I don't think we should be cutting huge tracts of forest for solar panels, but I also don't think we need to preserve every single tree. And I think there's a need, there's going to be a need for both. So that's one thing. And the other thing I think, and this really speaks both to the offshore wind conversation and to the solar conversation, I think it's a huge mistake to think of the status quo as fine. If we continue on the trajectory that we're on in terms of emissions, there will be palm trees in Rhode Island. And that's a very different habitat than we have now. Now, it's not going to happen next week or next decade, or even maybe by the end of the century. But if we burn all the rest of the fossil fuels that we have left to burn, we're looking at an unrecognizable planet. And in fact, sea level rise that will wipe out a large part of our state. So we know we don't want that. But I think oftentimes in the conversation about solar and wind, it's like, oh, you know, it's not what we are used to here. We have benefited from oil and gas and coal production all over the world at the huge detriment to the world's biodiversity and the huge detriment to our climate. And we don't happen to have that production here in Rhode Island. And what we're talking about now is a transition to actually energy independence, to making our own energy here. And we are going to see the effects of that. We can't do that without seeing some effects. We have been fortunately kind of oblivious to seeing it in our backyard relative to much of the rest of the world. And we have an opportunity now to do it in a cleaner, more efficient, more environmentally and more human-friendly way, but we are going to see it in some places. And that's a trade-off we have to recognize if we want to fight the elephant, if we want to be aware of the elephant in the room, which is climate change.
Great points. Yeah, and I'll add it's the great points made by Charles and Stephen, that when we think about what is it going to take, when we're thinking about what we need for the future and what we're building towards right now, is having a diversification of energy sources, right? And that includes energy efficiency. Somebody brought up in the chat the good question about, like, well, why aren't we conserving? Yes, and in fact, Rhode Island is like usually among the top 5 national programs in energy efficiency, is one of the best tools that we've had for a really long time to reduce our carbon footprint while also saving people money as well. And for me, I think that those programs could even be better, just because you're nationally recognized doesn't mean that they're reaching everyone, in particular low income households, to save more on energy there. And they tend to have the lower carbon footprint, as Stephen pointed out, to really making sure that there is an equity in how the energy burden is distributed. So one, yes, energy efficiency. Stephen also talked about offshore wind. We haven't gotten into talking about hydro or biomass or other types of sources out there. But the key is we need to shift away from fossil fuels. And that's one of the things typically that we're trying to really advocate for at the State House. Yes, we can all talk about costs, but there is a cost to inaction. And right now, climate change is accelerating at a pace that we and nature cannot keep up with, and people's lives are being uprooted and impacted. So right now, you could hear the utility at the State House talk about there's a cost to ratepayers for transitioning to renewable energy. And yes, there is a cost to transition, but I think it goes back to some of the points that Charles and Stephen made. How do you do that transition? How do you plan for it in the most cost-effective way, and also cite things properly, and do that in a way that people are better off and also habitats are better off? But we cannot take a pause or wait for the perfect, because we're going to see an uptick in natural gas and oil production if we cannot get these renewable energy projects off the ground.
Priscilla, if I could just jump in on a couple of things. So I would say, yes, efficiency is important, but one of the two best things we can do for efficiency will actually both increase our electricity consumption. So one of them is the switch to electric vehicles, and the other is the switch away from home heating by gas and oil to heat pumps. Both of those are way, way, way more efficient than current technology. But they will require more electricity because they're switching from combustion on site to electricity production. And so I'm all in favor of efficiency, but by far those are the two most efficient, those are the lowest hanging and biggest fruit for efficiency. And so yes, and I guess is one thing. And the second thing I would say is there is a transition cost. But actually, in the long term, I am very optimistic that this is a savings. We are not going to be subject to the kind of crazy price fluctuations on the natural gas market if we're producing our power here in Rhode Island. Yes, it's going to take time to integrate storage, to think about geothermal storage of heat, et cetera. I'm happy to happy to talk about that offline or at a future time. So yes, there's a transition cost, but I think in the long run, this is the smart thing to do from a cost perspective. Solar with storage is now competitive in many regions of the world with any other form of electricity production. In another decade, it won't even be close. So let's start the transition now. It's going to take time. We don't have much time, so let's go.
Couldn't agree more. And then one other point I'll just quickly stress, and Stephen, please feel free to chime in on this one. I think you alluded to it during your presentation very well, that when it comes to issues of inequities and how things are cited, that many of us have had the privilege of not having a natural gas facility or oil refinery in our backyards, but that's not the case for communities that are overburdened by pollution. So really looking at things like solar and renewable energy offers an opportunity to shift away from those polluting sources that are harming the health of communities. And here in our own backyard in Rhode Island, I always point to the south side of Providence, where I grew up, where there is a natural gas plant facility, and what that means for the residents in that community. So the other thing comes back to policy. I think what we're getting at is that there's not one thing that's going to solve the climate crisis. It takes many different solutions, and so there's definitely part of those solutions. Someone asked about a carbon tax and dividend model, which politically we have not been able to get across the board statewide, although I saw Senator Shelton Whitehouse at an event a couple months ago, and he's feeling optimistic that at some point we'll see something pass through Congress. However, there have been other pieces of federal legislation that are going to accelerate the adoption of more renewable energy, electric cars, and so on. But it's Stephen, you wanted to speak to any of that related to policies?
Yeah, I mean, I think I far be it for me to disagree with Senator Whitehouse on the likelihood of a carbon tax. But I would say that I would bet a lot against it in the near term. And I would also say that if a carbon tax gets passed, it will only get passed if it's so low as to be kind of irrelevant. Because in order to get enough political support for a carbon tax, you'll have to make it cheap enough for very heavily polluting industries to not object too much. And if that happens, then it won't really change behavior. So we need a tax that's, $100 a ton, not $4 a ton. But if we actually manage to pass a carbon tax, it will be, in my opinion, likely to be so low as to be meaningless. So I don't think that is going to be the path to salvation on this front, but I do think that the economics of solar and wind are already very strong and about to be even stronger. I did notice in the chat, and I see there's a ton of chats coming in from everybody. Somebody asked about storage. Storage is the hardest part of renewables. A part of that can be addressed by the fact that solar and wind do not produce at the same time, or not always. They're not perfectly correlated. So sometimes at night the wind is blowing. So you want a mix of both. Pumped hydro in many places, although not in Rhode Island because we're kind of flat, is another very important storage mechanism. But even here in Rhode Island, there are people doing really incredible things with batteries that will not help us with summer versus winter, but will help us with day versus night. There's no reason that we can't be starting on this path full bore, and storage will come. I'm very confident of that. If we wait for storage to be perfect, it's too late, and we don't need it to be perfect right now. Yes, there is a carbon border adjustment mechanism. I'm happy to talk about that at another time. So anyway, I want to come back to this idea that if we let the perfect be the enemy of the good, and that means never cutting a tree or never or waiting for storage to be perfect, it's, we're way too late already. And I do want to also point out that we live in a very dynamic world. And if in 50 years, solar panels are obsolete because everything is running off fusion, we can pull those panels back up. Like, it's not impossible for land use to change. Remember that we lived in a deforested state. People in Rhode Island lived in a deforested state. And now we have, 60% forest. And that's true all over New England. New England was largely deforested, and now it is largely forested. I'm not suggesting that we need to clear all forests, or even a large percent. If we even cleared 1% of our forests and put up solar panels, that would put a huge dent in our need for electricity. And to me, that's worth considering. It's not worth considering doing it in every place, but there are places where that's worth thinking about. And that doesn't mean that we shouldn't also put them on parking lots, and it doesn't mean we should also put them on rooftops. We need all, if you had a chance to read that brief op-ed that Priscilla sent around, I think we need all. But to have a blanket prohibition, or even a sort of strong bias that really makes it impossible to ever cut a tree, I think is short-sighted and counterproductive, in my opinion.
Thank you, Stephen. And I did post on the chat a link to Stephen's recent op-ed in the Providence Journal. Please read it. Also a link to our advocacy updates and newsletter. Please take a look at the type of policies that we're advocating for at the state level. We'll make sure that in a follow-up email with the recording that we can also provide those resources. And also very timely, in the most recent Audubon member report, which Paige could correct me if I'm wrong, we will be posting the editorials as blogs in the coming weeks. Charles wrote a great editorial about offshore wind from the avian research perspective, and why we can cite offshore wind responsibly, and why we desperately need it to combat climate change. And then also in that same quarterly report, I wrote an editorial emphasizing some of the points that Stephen made much better than me about the cost of inaction, and really how the status quo is not working, and climate change is the biggest threat we all face, and how that's the driver for the advocacy that we're currently working on. So it is 7:04, we're over time, and there's so much great dialogue in the chat. We will download the chat so we can continue reading through your comments. I really appreciated that attendees were talking to one another in the chat and sharing some good thoughts and provoking perspectives. So Stephen, you get the last word. Thank you for being our honored guest speaker and for sharing all the amazing science and perspective that you have with us today. We're really lucky to have you on the Audubon board.
Well, I really appreciate the opportunity to speak. I don't have any pearls of wisdom to share as the last word, but I will say that I'm very easy to find if you want to follow up with questions or comments. It's just Stephen with a PH _ Porder, PORD as in David ER, which is a bit confusing. So Stephen _ Porder brown.edu. I'm happy to try to answer any questions, although as you've seen from this call, often Charles and Priscilla have more knowledge than I in some areas. Everybody has their own expertise. But thank you for attending, and thank you for indulging in a conversation. This is a complicated issue, and it's going to involve trade-offs that we're all going to have to be a little bit unhappy about in order to get to where we all need to go. And I appreciate you taking the time to think about it with me.
Thank you all. Have a good night.
Bye, everyone. Be well.